Welcome back to Wildcat Academy. Today we're going to be solving exponential equations using logarithms. You may have watched our previous video where we solved exponential equations using the common base method, where we would make use of the fact that like 2 to the x is equal to 2 to the y, and we would set x equal y because the exponents had to be equal to one another, and then we would solve. In cases like example 1, we cannot rewrite 42 as base 3. We know that 3 to the third power is 27 and 3 to the fourth power is 81. So our answer is going to be between 3 and 4, but we don't know what decimal value that's going to be. So we'll have to use the inverse function of an exponential, which is a logarithm, to cancel that base in order to solve this. So we will take the logarithm or the inverse function of base 3 to both sides. We'll use log base 3 of 3x, and we'll use log, and also take log base 3 of 42 on the right hand side. Now I don't want to show this on this one problem, but from here on out we'll just understand that log base 3 of 3 cancels, and the exponent is all that's left. But that we can rewrite this using our power rule, logarithm power rule, as x log base 3 of 3. And this log base 3 of 3, that's 3 to what power is 3? Well, that's 1. So this ends up being 1 times x is equal to log base 3 of 42. And that again is just equal to 1. And we'll rewrite that. We now type this in the calculator. Most modern calculators, you can change the base. Older style calculators, you would had to have used the change of base formula and used log base 42 and log base 3. So sometimes it is handy to be able to rewrite this as using the change of base formula as log base 10 of 42, log base 10 of 3. Old style calculators only have base 10 stored in them, so you'd have to use enter it in this way in order to get the decimal value. And log base 3 of 42 is 3.4022, and that is our solution. On example 2, we have a coefficient 5 times the base 4 with the exponent x minus 2 is equal to 175. We want to divide both sides by 5. This allows us to isolate this base and exponent. So that's going to be our key step in solving these. 4 to the x minus 2 is equal to 35. And then we will want to take log base 4 of both sides. 4 to the x minus 2 is equal to log base 4 of 35. Now the right hand side is just a decimal value, even though it doesn't appear to be that at this time. It is just a number. And with this side, we'll simplify down into x minus 2. Log base 4 cancels the base 4 here, and we're just left with the exponent. And then this side is going to be 2.56464, and you're welcome to leave that like that and then just add 2 and do it all in one step in the calculator. I think that would be advisable. Ends up being writing a lot of decimals if you don't do that. 4.56. Try to be consistent here and use 4 decimal places. Before 6. Go ahead and do all the way to the 10,000th place. Alright, so that ends up being example number 2. The biggest difference in example 1 and example 2 is that coefficient we had to take care of in the very first step on example 2 by just dividing it off. And remember, we're just trying to isolate that exponential term prior to taking the inverse function of both sides, which happens to be a logarithm in this case. Alright, so example 3. Here we can see we have the exponential term, but we have added 3 to both sides, so we're just going to do the opposite. We're going to add minus 3, subtract 3 from both sides, or add a negative 3 to both sides. We will get 8 to the 2x minus 4 is equal to 205 when we subtract that 3 from both sides. And then we'll take log base 8 of both sides. So log base 8 of 8 to the 2x minus 4 is equal to log base 8 of 205. This is a decimal value. Over here we have 2x minus 4, and that is going to be, we're going to type log base 8 of 205 into our calculator. And again, you do not have to list out this decimal. In fact, we're going to carry it out to a few decimal places here. And then in the calculator, while it's still in there, I will add 4 and then divide by 2, and we will get the final answer to be 3.2799. Again, all I did was add 4, and we got 6.5598 divided by 2 and got 3.2799, and that will be a rounded value. All right. On example 4, so we have a multiply or coefficient of our exponential term and a value added on to that left-hand side, and we have the constant on the right-hand side. So we will add 4 to both sides. We'll get 357. We'll get 3 times 7 to the 2x minus 5. And then we'll divide by 3. 7 to the 2x minus 5 is equal to 119, I believe. And then we have our base and exponent isolated, so we will take a log base 7 of both sides. Kind of highlight that really good this time. 7 to the 2x minus 5, and then of 119. So just kind of like taking the square root of both sides of an equation. We're going to take log base 7 of both sides, and then on this left-hand side, all we're left is with the exponent. That's the whole purpose of us doing that. And on the right-hand side, that is just a number value, and we can write out that decimal if we want to. From here, I would type this in the calculator and get the decimal to be 2.4559836, and from there I would just add 5 while it's still in the calculator, divide by 2 rather than write it out several times, and you will end up with the final answer of 3.72799. We want to keep consistent there. We just want 4 decimal places, so 3.7279 will round to 3.2780. Alright, that winds up this video on how to solve exponential equations using logarithms. If you found this video helpful, be sure to hit the like button and subscribe to the channel for more great videos from Wildcat Academy. And if you have ideas for great videos, you want to see more videos like this, leave a comment down below. Alright, see you guys next time.